All right, let's begin with the class. Inshallah, we are going to resume the integration general category. In the last class we covered different aspects of integration. We reviewed P1 integration, then we did the integration of exponential, logarithmic, and trigonometric functions. Then after that, I covered few examples of those as well. Then we covered integration by recognition, in which we learned that if there is a function in the denominator and the differentiation of that is there in the numerator, then the integration of that will just be, we take ln with the denominator. If there is a function in the denominator and the differentiation of it is present in the numerator, then we just have to take ln with the denominator, and that will be our final answer of the integration. And if there is a constant that we have taken as common, or if there is a constant outside, then we have to take that constant as well. And because if it's indefinite integral, then we have to take plus c as well. And in integration by recognition, we learned that the function can be linear or non-linear. And then we covered the integration of tan x and cot x as well, using the integration by recognition rule. And then we locked that you can remember it as a rule. However, this has been derived using integration by recognition. So if we know how to use integration by recognition, we can easily find out the integration of tan ax plus b and cot ax plus b. So tan ax plus b is negative ln cos ax plus b upon a plus c, and cot ax plus b is ln sin ax plus b upon a plus c. Now, moving on, covering more aspects of integration. Now, usually, when you were covering trigonometry, I told you people that trigonometry is extremely important, because trigonometry is one area that will be used everywhere. Whether you differentiate, whether you use differentiation, whether you do differentiation, whether you do integration, or whether you do differential equations, numerical solution of equations, even in complex numbers, vectors is an exception. There is no involvement of trigonometry in vectors. But even in vectors, to find the angle, we use cos. However, there is no use of trigonometric identities over there. But if we talk about complex numbers, even in complex numbers, there are few questions in which we have to use trigonometric identities. So this much importance we have to give to trigonometry. So this means if we have not practiced the questions of trigonometry, if we have not practiced sufficient past papers of trigonometry, then we need to solve and try to ensure that we solve all such past papers. Because if trigonometry is strong, then lot of different areas will become strong, inshallah. Because remembering the rules of differentiation integration is simple, but once we have differentiated, then after that, using trigonometric identities and then reaching the final answer becomes a big challenge if we are not strong with trigonometry part. So trigonometry has to be very, very strong. Okay, so today, inshallah, we are going to cover up the remaining explanation of integration general category. The first, the aspect that we have to cover mainly is use of trigonometrical relationships in carrying out integration. This is one of the bullet points in your P3 syllabus, which I have given, which I have named. Basically, I've given the heading of that bullet point. That bullet point is used as a heading over here. This is a bullet point in your syllabus. Use of trigonometrical relationships in carrying out integration. What does this mean? Now, at times, we have to use double angle formula to integrate. And at times, in part number 1, the examiner will ask us to prove an identity. Now, proving identity questions were there in trigonometry topic as well. However, those questions were very less. In trigonometry topical past papers, proving identity questions were less. Now, in integration, general category, there will be a lot of questions in which the first part will be proving a trigonometric identity. Proving will not be that difficult. You can prove it easily. But then you have to use that identity in part number 2 to integrate. So this means now we have to use trigonometrical identities to integrate. And if there is no trigonometric identity that we have proved in that particular question, then in such cases we use double angle formula. So how to use double angle formula, when to use double angle formula, when to use trigonometric identities, how to use trigonometric identities, this is what we are going to learn, inshallah. So this is a very important part, right? Note, integration of trigonometrical functions is quite different from differentiation of trigonometric functions. Now, this note is extremely important because what the biggest problem is, once the students have learned to differentiate, they try to follow the same pattern in integration, which is very wrong. Now, let me give you an example. If you have been given sine cube x, then you know that sine cube x is basically sine x or whole cube. सही है ना, ये बात आप जानते हैं कि sin cube x जो है वो sin x का whole cube होता है. So if you want to differentiate sin cube x, how will you differentiate it? How will you differentiate? So you know the rule. First you deal with power, then you deal with the function, then you deal with the angle. Now dealing with the function, dealing with the power means you multiply the power and you subtract the power by 1. Now, when you are dealing with the power, the function and angle remains intact. You will not be touching the function and angle. So if I am multiplying the power, it's 3 sine. The power gets subtracted by 1. It becomes 3 sine square x. Then forget the power. Then remember the function that is inside the bracket. Over here, just forget the power and see there's sine x. Then the second step is differentiation of the function. And the differentiation of sine x is cos x. Then forget the trigonometric function, forget the power, just remember the angle. And then the differentiation of the angle will be multiplied, and that is 1. So firstly, we deal with the power. The function and angle remains intact. Then we deal with the function. The angle remains intact. Then we deal with the angle. So multiplying the power, subtracting the power by 1, multiplying the differentiation of the trigonometric function, that is the differentiation of sine x over here, which is cos x, then multiplying the differentiation of the angle, which is x, and that is 1. Now the students know how to differentiate using PFA. They try to use the same strategy while they are integrating. Normal and common error you see is this, that I've created in the note. When they see sine square x, they know that first they have to deal with the power. But they know now they know that they don't have to multiply the power and subtract it by 1. Rather, they should add the power and divide the new power. So they try like this. They try to make sine square x sine cube x. And then the new power 3 is divided. Then the differentiation of the function, that is sine x, they try to divide that. वहां पर multiply करते थे. Differentiation में we multiply the differentiation of the trigonometric function. Over here they divide. और फिर angle की differentiation, then the angle differentiation is also divided. So this rule is a big blunder. This PFA is not allowed. One thing you should remember as a rule, that there is no link over here between the differentiation and the integration part. The way in which we used to differentiate trigonometric functions is quite different from integration of trigonometric functions. This is what the note has already mentioned. Integration of trigonometric functions is quite different from differentiation of trigonometric functions. Do not try to follow the PFA rule. Now the question is, if we have sine square x and we have to integrate it and we cannot use PFA, then what we actually have to do? Always remember one thing, even if you forget this, right, and you mistakenly do this, and when you are dividing by cos x, then you should have an alarm sound over here. Like you should be aware. You should be like you should save yourself from mistake. How? By realizing that you can never divide with the variable. Variable से कभी divide नहीं हो सकता. Integration में एक उसूल याद रखना. जब मैंने e power fx की differentiation कराई तो मैंने e power fx नहीं लिखा, मैंने लिखा e power ax plus b. And when I integrated, I said e power ax plus b as it is copied, and then the differentiation of the power will be divided. But we were dividing with the constant only. And that is why I mentioned the power will always be a linear function. So during integration, you can never divide by the variable. If you have to ever divide by the variable, then there is something wrong in your working, and that method should not be followed, right? So this is something that should you should pick this up whenever you are dividing with the variable. So even if you are mistakenly following the PFA rule over here, and if you're dividing with cos x, you should realize that this is not the right method. गलती से भी cos x से divide कर रही हो या किसी और से divide करने की कर रहे हो आप लोग, और अचानक आपको घंटी बजे, तो आप फौरन इस मेथड से रुक जाए. घंटी बजनी चाहिए, दे शुड अलार्म साउंड शुड ring in your mind and you should save yourself from that mistake. Now how do we do that? मतलब क्या करें? अब अगर ऐसे नहीं तो सर कैसे करें फिर? तो ऑलवेज मैं आपको कुछ टिप्स दूंगा. देखिए मुख्तलिफ एग्जांपल्स, आई विल गिव यू, आई विल टीच यू डिफरेंट एग्जांपल्स एंड अलोंग विद दैट आई विल गिव यू डिफरेंट टिप्स and you have to follow those tips. So if we are integrating sine square x, always remember that whenever we are integrating sine square x and cos square x, we have to use the double angle formula of cos. Always remember this. Whether we are integrating sine square or cos square, whether it's sine square x, whether it's sine square 2x, whether it's sine square 100x, if there is a power of 2 on sine or cos, whether it's cos square or whether it's sine square, you have to use the double angle formula of cos. जब भी sine square angle होगा या cos square angle होगा, आपने cos का double angle formula इस्तेमाल करना है. ये बात अपने दिमाग में बिठा लें. अच्छा कैसे? If we look at the formula sheet, then there are 3 different versions of double angle formula of cos that we see. And this is the general version that we will not see, that we don't need actually. If we have to integrate cos square a, then we need to use cos 2a is identical to 2 cos square a minus 1. If we have to integrate sine square x or sine square a, then we have to use the identity cos 2a equals 1 minus 2 sine square a. So these two will be used whether we have to integrate cos square or sine square. We will be using the double angle formula of cos. Now the tips and guidance that I am giving you is extremely important. जब भी sin square cos square की इंटीग्रेशन होगी, आप cos का डबल एंगल फॉर्मूला यूज करेंगे. अच्छा, अब cos का डबल एंगल फॉर्मूला, व्हाट इज द डबल एंगल फॉर्मूला ऑफ cos? So we know that cos 2x is 1 minus 2 sin square x. That version of double angle formula in which sin square is involved. So cos 2x is 1 minus 2 sin square x. Now because we have to integrate sin square x, so we will make sin square x the subject. So if we make sin square x the subject, then it's 1 minus cos 2x divided by 2. So sin square x is 1 minus cos 2x divided by 2. Now in place of sin square x, we are going to put 1 minus cos 2x divided by 2. So we are not going to integrate sin square x, rather sin square x is identical to 1 minus cos 2x upon 2. So we are going to integrate 1 minus cos 2x upon 2. Now we know that whenever there's a constant, we can take it out. It's not essential. Compulsory नहीं होता ये constant को बाहर ले जाना. It's not compulsory. However, it's recommended. Because even if you are applying the limits, then you don't have to write this divide by 2 again and again. So what I do usually, if a constant is being multiplied or divided, I take it outside the integral sign. So I do not have to rewrite it again and again. This works best for me. I think it will work best for you as well. However, if you're more comfortable taking the constant inside only, not outside the integral, then I have no issues with that. You should just see whichever way you are comfortable with, right? But this is my strategy. I always take constant outside. So if I said that whenever I have to integrate sine square and cos square, I will use the double angle formula of cos 2x. This is what I have said up till now. और कुछ मैंने नहीं कहा. जब भी साइन स्क्वायर या कॉस स्क्वायर की इंटीग्रेशन करनी है, कॉस का डबल एंगल फॉर्मूला यूज होगा. इसमें कोई ऐसी बात कही नहीं मैंने कि बहुत मुश्किल बात कही हो. सो आई हैव टेकन 2 outside. It's 1 upon 2, 1 minus cos 2x. Now we know that integrating 1 is x. 1 when integrated gives us x. Minus will give us minus. The integration of cos 2x is sin 2x divided by 2. Because this is indefinite integral without limits, so we will take plus c at the end. Then if we want to leave this as our final answer, this is perfectly fine, no issues at all. But we can also multiply with half x minus sine 2x divided by 4 plus. So even the above form is acceptable, the below form is acceptable, no issues at all. The bottom line is we have not used PFA, we have not treated it the way we used to treat differentiation of such functions. we have treated it very differently, बहुत अलग तरीके से किया है. And the suggestion is that whenever you are integrating sin square or cos square, you have to use the double angle formula of cos. ये आपने जहन में रखना है बात को, सही है. जब भी sin square cos square की इंटीग्रेशन करेंगे तो आप डबल एंगल फॉर्मूला का इस्तेमाल करेंगे, cos के डबल एंगल फॉर्मूला. sin स्क्वायर हो गया. अच्छा अब देखिए sin स्क्वायर 2x भी देख लेते हैं. sin स्क्वायर 2x अगर आप देख लेते हैं तो वो क्या फर्क आया, व्हाट इज द डिफरेंस. आपने कहा सर sin स्क्वायर x में आपने कहा था, अब sin स्क्वायर 2x आ गया. Not a big deal at all. Sine squared, whether it is sine square 2x, whether it's sine square 50x, whether it's sine square 100x, doesn't matter. I have just talked about sine square. No matter what the angle is, if you have to integrate sine square, then you have to use the double angle formula of cos. That's it. But sir, if over here it's 2x, and in this double angle formula we see x, so what we should do? We should simply replace this x with 2x, and because I am doubling this x, then I have to double this 2x and make it 4x. That's it. Let's suppose if we have to integrate sine square 100x. Now I am multiplying x by 100. So I will multiply 2x by 100 and I will make it 200x. As simple as that. It will become 1 minus cos 200x upon 2. Not a big deal at all, right? So over here I have to deal with sine square. I have to integrate sine square 2x. So using this, because I've already made sine square x the subject, from the double angle formula of cos, I have made sine square x the subject. So if I replace this x with 2x, if I replace this x with 2x, because cos 2x was 1 minus 2 sine square x, so cos 4x is 1 minus 2 sine square 2x. So the sine square 2x will then become 1 minus cos 4x upon 2. But we have already made sine square x the subject, so we can directly use this as well, that if we double x and we get 2x, so this 2x will become 4x. डबल एंगल फॉर्मूला का इस्तेमाल किया, बस याद ये रखना है, व्हेन एंगल चेंज हो रहा है, डबल हो रहा है, तो हर जगह डबल होगा. थ्रू आउट इट विल डबल. इफ इट्स बीइंग ट्रिपल, देन थ्रू आउट इट विल ट्रिपल. यू विल हैव टू ट्रिपल इट थ्रू आउट. Whatever change you are doing, you have to do it throughout. So then sine square 2x is 1 minus cos 4x upon 2. Then again 2 is 1 upon 2 is taken as taken outside. Integrating 1 minus cos 4x, 1 integration of 1 will give x. Integration of cos 4x will give sine 4x upon 4. Indifferent table will take plus c. We can leave this as a final answer, or we can give this as a final answer as well. No big deal at all. Then if we deal with cos square x, I will give you time to copy, don't worry. Then again, if it's the matter of cos square, then I've already suggested whether it's sine square or cos square, you have to use the double angle formula of cos. So if it's cos square x or cos square 4x, you will use the double angle formula of cos. And the double angle formula of cos 2x, the version will change. Previously, it was cos 2x equals 1 minus 2 sine square x. As I've shown you in the formula sheet, there are multiple versions. Over here, it's cos 2x equals 2 cos square x minus 1. Cos 2x is identical to 2 cos square x minus 1. So if we take cos square x as common, then cos square x will become cos 2x plus 1 divided by 2. Cos square x is cos 2x plus 1 divided by 2. So now I will integrate this. So cos 2x plus 1 upon 2, the 1 upon 2 is taken as outside. Then cos 2x plus 1 integrated, cos 2x is sin 2x upon 2, and the integration of 1 is x. So we can give this as our final answer. Then if we talk about cos square 4x, then I will replace this x with 4x. I've multiplied it by 4. So over here, this 2x will also be multiplied by 4 and will give us 8x. So it's cos 8x plus 1 divided by 2. So then 2 will be taken outside. 1 upon 2 will be taken outside. Cos 8x plus 1 will be integrated. Cos 8x is sin 8x upon 8, and the integration of 1 is x. So the bottom line is, whenever we have to integrate sin square x or whenever we have to integrate sin square or cos square, whether it's x, 2x, 100x, 200x, 1000x, doesn't matter. If it's a matter of integrating sin square or cos square, then we do not need any identity. We only need to look at the double angle formula of cos. That's it. एक बात लॉक कर ली, साइन स्क्वायर कॉस स्क्वायर के इंटीग्रेशन के लिए आपको कॉस का डबल एंगल फॉर्मूला देखना है. पार्ट नंबर 1 में वो कोई आइडेंटिटी प्रूव नहीं करवाएगा, आपको डायरेक्ट कहेगा साइन स्क्वायर या कॉस स्क्वायर को इंटीग्रेट करो. आपको फौरन घंटी बजनी चाहिए कि हमें कॉस का डबल एंगल फॉर्मूला इस्तेमाल करना है. आई थिंक आई हैव मेड माय सेल्फ वेरी क्लियर ओवर हियर. Copy this down and acknowledge. Write then and clear in the chat so that I can move forward. जी देवेंद्र, सेकंड वन में क्या मसला है? बस खाली एक्स को 2x किया है ना? आओ माइक पे।
यस।
ये वाले की बात कर रही हो?
जी सर।
कोई चेंज नहीं है ना बेटा, ये आइडेंटिटी समझ में आ गई ना? इसमें इस एक्स को मैंने 2x कर दिया तो ये 2x 4x हो गया, बस डबल हुआ है।
अच्छा।
आइडेंटिटी है ना? ये x को मैंने 2x, क्योंकि मुझे साइंस को 2x आ गया तो मुझे यही यूज करना है। लेकिन बस अब x की जगह 2x है तो मैंने यहाँ 2x लिखा हुआ है। तो फिर इस 2x को मैं 4x कर दूंगा। जो एंगल है वो डबल होंगे, बाकी कुछ डबल नहीं होगा। सब कुछ मल्टीप्लाई बाय 2 नहीं हो रहा। 2 साइन स्क्वायर एक्स अलग चीज होती है, साइन स्क्वायर 2x अलग चीज होती है। पूरे फंक्शन को 2 से मल्टीप्लाई करूंगा तो ये 2 माइनस 2 cos 2x हो जाएगा। लेकिन अभी मैं सिर्फ एंगल को 2 से मल्टीप्लाई कर रहा हूँ तो ये x 2x बन गया, तो यहाँ एंगल और तो कोई नजर नहीं आ रहा। तो cos 2x है तो ये cos 4x हो जाएगा। यही चेंज मैंने किया हुआ है।
ठीक है सर, क्लियर है।
कॉपी कर लिया?
यस सर, ऑलमोस्ट।
चलो कर लो फटाफट, तो बता दो फिर। ऑलराइट, मूविंग फॉरवर्ड। अब तक हमने सीखा कि that whenever we are integrating sin square cos square we will use the double angle formula of cos, right? Now whenever we have to integrate tan square, we will use the identity that links tan square and sec square. Now this identity, up till now we were using this identity for integrating sin square and cos square. For integrating tan square, I will use this identity. For sin square and cos square, I will use the cos double angle formula of cos. And for integrating tan square, I will use this identity because I don't know how to integrate tan square. So I know that 1 plus tan square is sec square, and tan square theta will be equals to sec square theta minus 1. So rather than integrating tan square theta, I will integrate sec square theta minus 1. And we know that the sec square theta integration is, the integration of sec square theta is tan theta, and the integration of 1 is theta. So this is what I've used over here. If it's tan square x, then we know that 1 plus tan square x is identical to sec square x. So if we make tan square x the subject, then it will become sec square x minus 1. Now, if I integrate sec square x minus 1, then the integration of sec square x is tan x, and the integration of 1 is x. So it's tan x minus x plus c. Tan x minus x plus c. Okay, so whenever we are integrating tan square, we will use the sec square x identity that links tan square and sec square. We will make tan square x the subject, we'll get sec square x minus 1. We know that the differentiation of tan x is sec square and the integration of sec square is tan. When we started with the general category, I've taught you that the integration of sec square is tan x, the integration of sec square x is tan x, the integration of 1 is x, and because we are dealing with an indefinite integral, we'll take plus. Now, similarly, if it's tan squared 3x or tan squared 100x or tan squared 1000x, doesn't matter. If over here in place of x, we are taking 3x, so even over here, we'll take 3x. The identity is not being multiplied by 3. The angles are being multiplied by 3. So tan square x, the angle x becomes 3x. So over here as well, the angle will become 3x. So tan square 3x will be identical to sec square 3x minus 1. The integration of sec square 3x is tan 3x upon 3, because we know that the differentiation of the angle is also divided. So it's sec square 3x is tan 3x divided by 3. The integration of 1 is x, and we'll take plus c as well because we are dealing with an indefinite integral. Right? So integrating tan square, and whenever we have to integrate sine square cos square, we use the double angle formula of cos. Whenever we have to integrate tan square, we have to use the identity 1 plus tan square x is identical to sec square x. ये जो मैं टिप्स दे रहा हूँ ना, बड़ी इंपॉर्टेंट है ताकि आपके जहन में रहे कि भाई स्क्वायर का चक्कर तो खत्म हो गया. सेक स्क्वायर tan square है, sin square है, cos square है. How to integrate? I have given the suggestion for that. Now, at times we see sin and cos together. Whether we are solving a trigonometric equation, in trigonometry we also looked at few examples in which we had to solve a trigonometric equation in which sin and cos were being multiplied together, and we had to solve an equation of that type. So even there, even in differentiation, there were a few questions in which you had to differentiate, and after differentiation, you got sin x cos x, and then you had to solve to find the values of x, but you couldn't solve unless and until you realize that whenever sin and cos are being multiplied, you have to use the double angle formula of sin. For integrating sin square cos square, you use the double angle formula of cos. But for integrating sin x and cos x, whether it's 2 sin x cos x, whether it's 5 sin x cos x, whether it's 100 sin x cos x, whether it's just sin x cos x, if you see sin x and cos x being multiplied together, अगर sin x cos x साथ multiply हुए हुए नजर आ रहे हैं, उनका product नजर आ रहा है, so whether you have to solve a trigonometric equation or whether you have to integrate that particular thing, you will use the double angle formula of sin. साइन का वो डबल एंगल फॉर्मूला है जिसके अंदर साइन कॉस हमें साथ मल्टीप्लाई हुए हुए नजर आते हैं. तो दिस नंबर डजंट मैटर. व्हाट मैटर्स इज even the angle doesn't matter. Angle x है, it's 2x, it's 100x, it's 50x, doesn't matter. What matters is if sine and cos are seen as a product and we have to integrate it, we will use the double angle formula of sine. So we know the double angle formula, the original double angle formula is sin 2x is identical to 2 sin x cos x. Sin 2x is identical to 2 sin x cos x. Right? Sin 2x is identical to 2 sin x cos x. So if we have to integrate 2 sin x cos x, we will write sin 2x in place of that, and integration of sin 2x will be negative cos 2x divided by 2 plus c. But if we are integrating 6 sin x cos x, then I will use this double angle formula. Now we know that the angle is not being changed. The coefficient of sin x cos x is being changed. So the entire thing is being multiplied by 3. Not only the angle is multiplied by 3, but the entire function is being multiplied by 3. So 2 sin x cos x when multiplied by 3 will become 6 sin x cos x. So if I'm going to use the double angle formula of sine, and if I'm making this to, if I'm converting 2 to 6 by multiplying it by 3, then even the sine 2x will be multiplied by 3. So I will get sine 3 sine 2x. 2 sin x cos x is sine 2x. So 3 times of this, that is 6 sin x cos x will give us 3 sine 2x. So I will now integrate 3 sine 2x. Then 3 is a constant. I can take it outside the integral. Sine 2x is negative cos 2x. Integration of sine 2x is negative cos 2x upon 2 plus c. We can give this as a final answer, or we can multiply 3 and we can write negative 3 upon 2 cos 2x plus c. Then if it's sine 2x cos 2x, now the coefficient is not being changed, but the angle is being changed. Doesn't matter. We are seeing that sine and cos are seen as a product. No matter what the angle is, we are going to use the double angle formula of sine. So if we use it, then sine 2x was 2 sin x cos x. Now we are seeing sine 2x and cos 2x. So the angles are being doubled. The angles are being doubled, right? The angles are being doubled. So if it's 2x over here, this 2x will become 4x. This 2x will become 4x. So that is why I've written that sine 4x is 2 sine 2x cos 2x. So if I have to integrate sine 2x cos 2x, then this is identical to sine 4x upon 2, sine 4x upon 2. And now I will integrate sine 4x upon 2. I have taken 1 upon 2 as outside. Sine 4x is integration of sine 4x is negative cos 4x upon 4 plus c. These are those examples in which examiner is not bound to give any identity in the question. Even if this is the first part of that question, you should be able to integrate it. So I'm repeating, when we have learned 4 things over here, we have learned 3 basically, 4 types of functions. If we are integrating sine square function, sine square angle, we'll use a double angle formula of cos. If we are integrating cos square angle, again we are going to use a double angle formula of cos. If we are integrating tan square angle, we are going to use the identity which involves sec square, which connects tan square and sec square. That is 1 plus tan square x is identical to sec square x. And then if we are dealing with the product of sine angle and cos angle, then we have to use the double angle formula of sine. तो हमने बेसिकली 3 चीजों का इस्तेमाल सीखा है 4 डिफरेंट किस्म के फंक्शंस के लिए. साइन स्क्वायर कॉस स्क्वायर की इंटीग्रेशन करनी है, कॉस का डबल एंगल फॉर्मूला. टेन स्क्वायर की इंटीग्रेशन करनी है, टेन स्क्वायर सेक स्क्वायर को लिंक करने वाली आइडेंटिटी. साइन एक्स कॉस एक्स का प्रोडक्ट इंटीग्रेट करना है, तो साइन का डबल एंगल फॉर्मूला. इसके अलावा if apart from that, if apart from these there is any other function that is to be integrated, let's suppose if sine cube x is to be integrated, then you don't know sine cube x is equal to what, or is sine 4x is to be integrated, then in that particular question in part number 1, the examiner would have told you to prove an identity and then use that identity to integrate in the subsequent part. अगर ये फंक्शंस होंगे तो आप डायरेक्ट इंटीग्रेट करने के काबिल होगे और एग्जामिनर भी डायरेक्ट एक्सपेक्ट करेगा. बट अगर इसके अलावा साइन क्यूब आ जाए, साइन पावर 4 आ जाए, कॉस क्यूब आ जाए, तो फर्स्ट पार्ट में वो आप देखेंगे कि आपसे ट्रिग्नोमेट्रिक आइडेंटिटी प्रूफ करवाई हुई होगी, आप उसको यूज करेंगे और यूज करते हुए आप इंटीग्रेट करेंगे. तो वो इंशाल्लाह हम सवालात में देखेंगे. Usually tan square and sin square in the same question, like tan square and sin square being multiplied. This is what you ask. Like integration of the product of tan square and sin square. Is this what you are asking? मानव. नहीं नहीं ऐसा नहीं होता. देखो ऐसा नहीं है कि कोई ऐसा वन ऑफ चीज आ जाएगी जो कि बहुत ही अलग सी होगी. प्योरली tan स्क्वायर sin स्क्वायर cos स्क्वायर या sin x cos x का प्रोडक्ट. अब tan स्क्वायर sin स्क्वायर का प्रोडक्ट लेट सपोज अगर आगे इंटीग्रेट करने के लिए, so then definitely there is something in part number 1 that the examiner will have asked you to show, and using that we could have integrated tan square sin square product as well, if there's something in part number 1 that we have shown by ourselves, that we have proved. तो वो सवाल जब आएंगे तो इंशाल्लाह दैट दोस विल बी मैनेजेबल. बस बाय डिफॉल्ट जो जहन में आना चाहिए वो मैंने आपको बता दी. राइट. पार्ट 7 तो समझाया ना मैंने, कितनी देर से समझाया जब एरिया। 2 sin x cos x की इंटीग्रेशन करनी है, ये तो मैंने कहा, यही तो 3 चीजें सिखाई हैं। 2 sin x cos x जो है वो sin 2x के बराबर होता है, डबल एंगल फॉर्मूला ऑफ sin 2x यहाँ दिया हुआ है फॉर्मूला। तो जब मुझे 2 sin x cos x को इंटीग्रेट करना था, मैं नहीं कर सकता, तो मैंने sin 2x को इंटीग्रेट कर लिया, क्योंकि दे आर आइडेंटिकल। sin 2x की इंटीग्रेशन नेगेटिव cos 2x अपॉन 2 प्लस c है। और फिर मैंने ये भी बताया कि अगर कोएफिशिएंट बदलता है तो मल्टीप्लाई करेंगे थ्रू आउट, और अगर एंगल बदलता है तो भी एंगल को मल्टीप्लाई करेंगे, तो इंटीग्रेशन हो जाएगी, जो कि हमने एग्जाम्पल 8 और एग्जाम्पल 9 में देखा। सही है, कॉपी कर लें एंड राइट डन एंड क्लियर सो दैट वी कैन मूव फॉरवर्ड। Right, so we have covered till here, right? Then there is a new addition that has uh, entered our syllabus from 2020. Before that, it was not a part of our syllabus. अब तो ये new edition नहीं रही, because it has become old, because now we are in 2023 and this new edition came in 2020। लेकिन notes में भारत ये new edition के तौर पे ही रहेगा और मौजूद है। The reason being the fact that there are so many topical participles that we have compiled from 2009 onwards to 2022, but this particular thing will only be tested in the questions of 2020, 2021 and 2022. So this is essential that we know that in old past papers this was not present. Now in differentiation I taught you a particular formula. The differentiation of tan inverse fx is f prime x upon 1 plus fx square, right? This I told you, I explained this to you when we were covering differentiation general category. No, implicit, differentiation of implicit functions. And I told you that this is derived using the concept of implicit differentiation. But deriving that was not a part of our syllabus. It was not essential for us to derive. If we just remember this formula, then also we are able to deal with it successfully. So tan inverse fx is f prime x upon 1 plus fx whole square. Now even, so this means the integration of f prime x upon 1 plus fx square will be tan inverse fx. This is one of the approaches that we can use to integrate a particular function of this type and convert it into tan inverse fx. However, there is another approach as well, and we are going to use that approach. जो रिवर्स प्रोसेस वाला तरीका है वो हम यहाँ फॉलो नहीं करेंगे। डिफरेंशिएशन के लिए आपने ये फॉर्मूला ध्यान में रखना है, but for integration you need to use another formula, and that is given in the formula sheet. That is why I don't want to confuse you at all. The simple thing is, in integration we have been given a formula, 1 upon x square plus a square is, when integrated, we get 1 upon a tan inverse x upon. Very simple. Whenever we have been given an integral and the denominator can be converted in the form x square plus a square, then the integration of that will be 1 upon a tan inverse x upon. It's written over here that if fx is a function and that is 1 upon x square plus a square, then the integration of fx will be 1 upon a tan inverse x upon. I just want to apply this. Apart from that, there are two more given as well, which we can deal using partial fractions as well. But as a rule, we can use that if the denominator can be written in the form x square minus a square, then the integration is 1 upon 2a ln x minus a upon x plus a. And if it's 1 upon a square minus x square, the integration is 1 upon 2a ln a plus x upon a minus x. Okay, so this is the formula that we have seen that is present in the formula sheet, and we just need to look at it. If the denominator can be expressed as x square plus a square, then the integration of that will be 1 upon a tan inverse x upon a. And if it's indefinite integral, we'll take plus c. Now, the first note tells you this formula is given in the formula sheet. Now, this formula is given in the formula sheet MF19. This is the first note. Then I've already told you this. The second note is extremely important. The coefficient of x square must be 1 for this formula to be valid. This means whenever you have to integrate and you have to apply this formula, you have to ensure that the coefficient of x square is 1. The coefficient of x square is 1. Coefficient, nothing is written, na? Kuch nahi likha hua na yahan par. When no coefficient is written, it means it's 1. So if there's a number written with x square, let's suppose it's whether it's a perfect square or not, whether it's 3, whether it's 4, whether it's 9, whether it's 16, whether it's 25, or whether it's the number is other than that, chahe wo number perfect square ho ya nahi, we have to make sure that the coefficient of x square is 1. This is very essential. This is what we need to ensure. We need to ensure that the coefficient of x square is 1. So if it's not 1, we'll make it 1. अगर 1 नहीं है तो 1 बनाएंगे. इसको जहन में बिठा लें अच्छी तरह से. मतलब जहन में नहीं बिठाना, फॉर्मूला शीट में गिवन है, मसला नहीं, इसको अप्लाई करना सीखना है. तो लेट्स स्टार्ट विद द वेरी फर्स्ट एग्जांपल. 1 upon 1 plus 4x square. We looked at the denominator and we realized that this could be written in the form x square plus a square. But how? So the first thing is to notice that the variable x square comes first and the square of the constant comes later. So I've rearranged 1 plus 4x square and I've written 4x square plus 1. In the denominator, I've changed the order. Variable first and then the constant. Variable first and then the constant. So I've swapped. 1 and 4x square have been swapped. Then the note number 2 told you were told using note number 2 that the coefficient of x square has to be 1. And if it is not 1, we have to take it as common and make it 1. So now, because there was 4x square, I have to take 4 as common and send it outside. So if I take 4 as common, then 4x square will become divided by 4. 4x square will become 4. 4x square divided by 4 will become x square. And 1 divided by 4 will become 1 upon 4. So I have taken 4 as common and I've taken it outside. So I have got the 4x square has been converted into x square and 1 has been converted into 1 upon 4. So it has now become 1 upon x square plus 1 upon 4. Now we know that the constant has to be written in the form of a square. So this is 1 upon 4. If we write it as a square, then we need to know that we need to make a square. A square has to be 1 upon 4. What will be a? A will be 1 upon 2. Over here, there's no need to take plus minus. We just need to identify the number. So if a square is 1 upon 4, a is 1 upon 2. So I've rewritten 1 upon 4 as 1 upon 2 whole square. 1 upon 4 को हमने a square form में लिखा है. सही है? Coefficient of x square is taken as 1. Coefficient of x square should be 1. So I've made it 1. I've made it 1. Then the 1 upon 4 will become 1 upon 2 whole square. Then once we have got 1 upon x square plus a square, then the formula is 1 upon a tan inverse x upon a. So what is a? A is half. X square plus a square and a is half. So as per that, 1 upon a, which means 1 upon half. 1 upon 4 was outside. It will remain outside. We just look at this. Look at this. X square is x square plus half whole square is 1 upon a tan inverse x upon a. So 1 upon a means a is half. So 1 upon half tan inverse x upon half. 1 upon half tan inverse x upon half. So 1 upon half will be converted to 2. X upon half will be converted to 2x. And now this 2 will be multiplied by 1 upon 4 and 2 upon 4 is 1 upon 2. So we have got 1 upon 2 tan inverse 2x plus. Let me repeat it once. एक दफा मुझे repeat करने दे. 1 upon 1 plus 4x square. We have to convert it इन द फॉर्म एक्स स्क्वायर प्लस ए स्क्वायर, उसके लिए एक्स स्क्वायर का कोएफिशिएंट मुझे 1 बनाना पड़ेगा, बट पहले ऑर्डर स्वैप करते हैं। 4x स्क्वायर प्लस 1 कर दिया, देन 4x स्क्वायर प्लस 1 को, 4x स्क्वायर को हमें एक्स स्क्वायर बनाना था, 4 को हमने कॉमन लिया, कॉमन लिया तो ये एक्स स्क्वायर हो जाएगा और यहाँ 1/4 हो जाएगा। कॉमन लेने के बाद 4 बाहर चला गया। नाउ दिस हैज बिकम एक्स स्क्वायर प्लस 1/4, बट वी नीडेड एक्स स्क्वायर प्लस ए स्क्वायर। तो 1/4 को रीराइट करना है ए स्क्वायर फॉर्म में। ए स्क्वायर फॉर्म में रीराइट करने के लिए ये 1/2 का होल स्क्वायर होगी। जब ये एक्स स्क्वायर प्लस ए स्क्वायर फॉर्म में हो गया तो ए पता चल गया कि हाफ है। आगे इसका आंसर मैं जानता हूँ कि 1/8 tan इनवर्स एक्स अपॉन ए है, तो 1/2 tan इनवर्स एक्स अपॉन हाफ, 1/2 होता है 2, तो 2/4 होता है हाफ, तो अल्टीमेटली बाहर हाफ आ गया, और एक्स अपॉन हाफ होता है 2x, तो ये 2x हो गया। तो वी हैव सक्सेसफुली इंटीग्रेटेड 1/1 प्लस 4x स्क्वायर, राइट? So are we clear with the application of this formula? That is a new addition from 2020 onwards and is given in the formula sheet. The the most common, the something that you need to remember, I've reinforced that multiple times, that the coefficient of x square has to be 1. And then the denominator has to be in the form x square plus a square. Yes. Copy this down and let me know if you're clear with this. Done and clear, right? Right, done and clear, so that we can move forward. All right, Alhamdulillah, this is done. Then moving forward towards another example, which is the last. Yes. Okay. Then we see another example that is written in the syllabus as well, that students should be able to integrate functions of this form. And this example has been written over there. So I've covered this as well as a second example, integrating 1/2 plus 3x squared. So firstly, we change the order variable first. So it becomes 3x squared plus 2. Then we need to make the coefficient of x square as 1. So I will take 3 as common. So if I take 3 as common, it will become x square plus 2/3. The 3 will come outside. It will become 1/3. Then x square plus 2/3, and 2/3 is to be written in the form a square. Now just check it out. If a square has to be equals to 2/3, then a will be equals to root of 2/3. And root of 2/3 means root of 2 divided by root of 3. So this is what I've written. 2/3 has become root 2 upon root 3 whole square. Because a square has to be equals to 2 over 3. So a has to be equals to root 2 over root 3. So this is root 2 over root 3 whole square. Now we have identified a. The formula is 1 upon x. If we need to integrate 1 upon x square plus a square, then it's 1 upon a tan inverse x upon. So 1 upon a means 1 upon root 2 upon root 3. Tan inverse x upon a means tan inverse x upon root 2 upon root 3. Now 1 upon root 2 upon root 3 will become, if you use calculator, if you are going to use calculator, then 1 upon root 2 upon root 3 will become root 6 upon 2. And x upon root 2 upon root 3 will also become root 6 upon 2. Because it's 1 upon root 2 upon root 1x upon root 2 upon root 3. So if we divide 1 by root 2 upon root 3, it will become root 6 upon 2. So root 6 upon 2 tan inverse root 6 upon 2x plus c. Then if we multiply this 3 with 2, then it becomes root 6 upon 6 tan inverse root 6 upon 2x plus c. So the integration of this is going to be root 6 upon 6 tan inverse root 6 upon 2x plus c. The same formula that we used in the previous example, we have used that. However, this was another example in which root was involved, right? So I think this is a similar example and you can easily understand it. Just copy it down and let me know if it's clear to you as well. Write done and clear so that I can move forward. All right, the explanation, the last aspect. In this general category, we see that there we'll have to integrate rational functions by means of decomposition into partial fractions. Uh, in algebra, we covered binomial and partial fractions. And we used to see that in the first part, it was a 5-mark question when we used to split into partial fractions. There were 3 cases of partial fractions, if you remember. And those 3 cases were focused on the denominator, linear factors in the denominator, repeated linear factors in the denominator, non-factorizable quadratic factor in the denominator. And then we also discussed about proper and improper fractions. If the degree of numerator is lesser than the degree of denominator, no need to add a constant before splitting. If the degree of numerator equals the degree of denominator, then we add a constant before splitting into partial fractions. So all the cases of partial fractions needs to be recalled. In algebra, we used to see questions in which the first part was partial and the second part was binomial. Now we are going to look at questions in which the first part is going to be partial and it is going to be treated in the same way as we used to do it in algebra. But the second part will be integration. So this means if we have to integrate a function, a fraction, we will use the partial fractions of that rational function to integrate that. Now, when we are integrating that, when we are integrating the partial fractions, usually we see that integrate the definite integral using the different rules of integration learned above. Now, the rules that we have already studied, those will be used. Normally, what is used? Integration of composite functions. So let's suppose if one of the partial fraction is 1 upon x plus 2 whole square. How do we integrate this? How do we integrate this? We'll use the rule of integration of composite functions. We'll take x plus 2 whole square to the numerator. It will become x plus 2 to the power of minus 2. And then we know how to integrate it. We add the power, we divide the new power, the differentiation of the bracket will be divided as well. So integration of composite functions is used. Then we know integration by recognition. At times we have to integrate 1 upon x upon x square plus 4, let's suppose. Then we know that the differentiation of x square plus 4 is 2x. So we'll write 2 over here and we'll write 2 outside as well. Then the differentiation is present in the numerator. The differentiation of the denominator is present in the numerator. So we take ln with the denominator. So it will become 1 upon 2 ln x square plus 4. So integration by recognition is also used. and then the newly added category. Because if the denominator is of the form x square plus 5, let's suppose, or x square plus 4, integrate 1 upon x square plus 4. The denominator is a non-factorizable quadratic factor, and if you have got 1 upon x square plus 4, then what will you do? Now this x square plus 4 is basically x square plus 2 square, which is of the form uh, 1 upon x square plus a square, and you will integrate that. So till 2019, you are not going to see this particular area, but from 2020 onward, this is another thing that you will be using. So in partial fractions, integration of अब तक बल्कि जितनी दफा भी आया है ना, मतलब mostly whenever this newly added category is tested, it is used, it has come with integration by partial fractions. So this is extremely important that the newly added category comes with partial fractions. So integration of composite functions or integration by recognition and newly added category. Why am I giving suggestions at all points in time that when we'll see this, you have to do that? Because the biggest challenges in P3 is we need to identify what kind of integration we have to do in a particular question. असल challenge ये है ये समझना कि यहाँ कौन सी किस्म की integration लगेगी. Once we have identified it, then integrating it is not a problem at all if you have a good command. But identification at times is a bit tricky, but वो भी मुश्किल नहीं है if you have practiced it. If you have practiced sufficient past papers of topical, if you have practiced sufficient topical past papers as well as yearly past papers, then this is not going to be a problem for you, inshallah. So it all depends upon your mindset, and the more practice you have, the better you will get. Then you will also see that once you have integrated in part number 2 using the partial fractions that you have done in part number 1, then when you apply the limits, then you have to show something. And for that, you will use the laws of logarithm to obtain the given answer. मैंने कहा था ना, laws of logarithm to trigonometry हर जगह use होते हैं. तो in the first part, you'll split into partial fractions. Then you will, in the part 2, you will integrate, and also you'll apply the limits. And once you have applied the limits, then you have to show something at times. And for showing, you will use the laws of logarithms, product law, quotient law, power law, etc., etc. So this is something that you will be seeing in this particular category. सही है? अब the explanations have been completed, right? We have completed the explanation of this general category. Alhamdulillah, all the things have been covered. Now, as far as past papers questions are concerned, I've covered several past paper questions of integration general category in the past as well. So I am going to upload the recordings of that. I will upload the past paper file of this new topic on LMS. I will upload the recording of today's class, and then I will upload the past paper questions as well of this category. So what you are going to do, you are going to review the notes of this category. Then the first few questions, like I've covered in the first lecture, I've covered question 1, 2, 3, and 4. So in the first lecture, you can look at lecture 1, question 1, 2, 3, 4, and after that you'll get to know how to solve the questions, and then after that you can definitely solve more and more questions, and the problems that are troubling you, you can watch the recording of that. And if the recording of that is not present, you can bring the problems to me. Okay, so that was it for today, and alhamdulillah, we have ended the explanation of this category. I'll be uploading the recordings. Just refer to that and complete and do as many questions as possible before the next class. See you in the next class. अपना बहुत सारा ख्याल रखिएगा. अस्सलामु अलैकुम व रहमतुल्लाहि व बरकातुहू. यहाँ तक बात समझ आ गई? किसी को कोई मसला तो नहीं है? मैंने पूछा नहीं मेरे ख्याल से. हाँ, पूछ लिया ना, बस सही है, इसमें तो कोई मसला नहीं है. वो तो ऊपर डन एंड क्लियर हो गया था ना, बस सही, इसमें कोई मसला नहीं. इंशाल्लाह once you are going to look at the recording, इंशाल्लाह everything will be fine. Okay, take care and remember me in your prayers. अपनी दुआ में मुझे याद रखिएगा, खास दुआ में. अपना बहुत सारा ख्याल रखें. अस्सलामु अलैकुम व रहमतुल्लाहि व बरकातुहू.